Hello and good afternoon, everyone. My name is Manoj. I am a research scholar at Agricultural and Food Engineering Department of IIT Kharagpur, and I'll be taking your live interactive session for the course Computer Vision. This course is taught by Professor Jain Mukhopadhyay from IIT Kharagpur, and what we'll be doing, we'll be solving some of the MCQ questions based on the previous week's content in front of you all. Okay. And my sincere request is please take a notebook and pen and try to jot down all the points, all the different critical aspects which are there in solving particular problem. Okay. And if any issue is there, please feel free to ask me. Okay. Feel free to ask me as well as raise your concerns. Okay. And please remember that your exam is approaching. Okay. So since it is approaching, please be very careful with the content which I have already presented in front of you and shared multiple times. Okay. So please go through it, read thorough, and uh, afterwards we can discuss the things. Okay. And if any issue is there, please. Yes, and apologies from my side. Okay, for starting the class late. There was some emergency issue. That is why I was unable to start on time. Okay, but I hope that you all will see the recording. Uh, you will try to contact me as well as you will try to solve these problems once again by yourself. Okay, so that your concepts become crystal clear. Okay, this is my sincere hope and advice. And let us begin the session with this, keeping this spirit up. Okay, let us begin the session and then we'll see how things goes. Yes. So the very first question for the present session is this one. Okay. Hope I am shared, but I am not shared. Okay, let share and then should be share. Show there. The very first question for the present session is this one. Consider the set of parametric equations x equal to t square plus 3t and y equal to 2t square minus 1 representing a 2D curve. Okay. Compute the tangent vector x dash t comma y dash t at t equal to 1. Okay. And your options are 5 comma 4, 3 comma 2, 1 comma 2 and 2 comma 2. Okay, these are your options. Let us see the approach. Okay. First of all, we have to understand that we have been given two particular parametric equations. Okay. X equal to t square plus 3t, y equal to 2t square minus 1. You have to compute the tangent vector x dash t, y dash t at t equal to 1. First of all, what you have to do, you have to take the x component and you try to differentiate it with respect to the value. So x dash t equal to differential of this particular part, dx by dt, simple procedure I am doing. So here what you will get 2t plus 3. Okay. Y dash t is 2 that will be taken outside. Then differential of t square is 2t. Okay. So 2 into 2t is 40. That step number 1 is done. Now try to evaluate at equal to 1. Okay. So x dash 1. Okay. At equal to 1. Then x dash 1. X dash 1 is nothing but 2 into 1 plus 3. 2 plus 3 is 5. X dash 1. Y dash 1, nothing but 4t, 4 into 1. Okay, t is equal to 1, so 4 into 1 is 4. Now you try to see what is the final answer. Final answer is 5, comma 4. Okay. XST and YDST values directly I have computed here, and I have found out the solution as 5 following. So this completes your first part of the first question only. Okay, there is nothing much to discuss here. Okay. Parametric equations directly have been given to us. We have to compute the tangent vector. Tangent vector is nothing but the differential, okay, or the slope component, which is x dash t and y dash t. Okay, x dash t and y dash t at t equal to 1 directly I have computed. Okay, and I have got the solution is 5. This marks my first question for the present session. Going forward, please try to take a note of it. Which of the following is true about Microsoft Kinect sensor? Microsoft Kinect sensor, it uses infrared laser light with speckle pattern, or if a point is at higher depth from the sensor, it looks more blurry, or uses the principle of structured light, or all of them. If you try to see here, so coming towards the second question, I hope you must have read it. Okay. Its correct solution is all of the above. The Microsoft Kinect sensor, it uses infrared laser light with a speckle pattern. If a point is at higher depth from the sensor, it looks more blurry, yes. And C, it uses the principle of structured light. All of the statements are correct. Okay. Let us analyze each statement. Okay. Microsoft Kinect sensor. Okay. It's the first generation Kinect. Okay. Kinect V1, which most commonly is referred in this type of particular questions. Okay. So here, what we are talking about Microsoft Kinect sensor. Okay. Now you try to see here. Option number A was it uses infrared laser light with speckle pattern. Yes, this particular statement is 100% true. Okay. It uses infrared laser light with spectacle pattern. This statement is true. Kinet V1 is the particular sensor which uses infrared laser projector cast a spectacle or dot pattern onto the scene. Okay. Then option B was if a point is at higher depth from the sensor, it looks more blurry. Yes, this statement is also true. As depth increases, the projected pattern spreads and becomes more blurred, which can reduce the accuracy. This is due to the decreasing density of the structured light points in sensor resolution limitations with it. Within depth. Yes, this statement is also correct. Okay. Particularly option number B, both these statements are correct. Yes, as the depth increases, the projected pattern spreads and becomes more blurred, which can reduce the accuracy. This is true. due to the decreasing density of the structured light points and sensor resolution limitations with the increasing depth. Now your C option was uses the principle of structured light. Yes, this statement is also true. Okay. Why true? Because the planet V1 uses structured light technology, where it is also known as where it uses the infrared pattern. Okay, in order to project and then distort the pattern. Okay, as it is done in case of IR camera, in order to compute the depth. Okay. So yes, all three statements are true. A, B, and C. All these statements are true. Hence, correct option will be all of the. Moving forward to the next question. Okay. Consider the coefficients of first fundamental form, which are given by E equal to 5, F equal to 1, okay, G equal to 3. The coefficients of second fundamental form S equal to 3, F equal to 7, G equal to 3. Now I have to compute the Gaussian curvature. Okay. Let's try to. Yes, I hope that you must have noted down the question. Okay. Consider the coefficients of first fundamental form are given by E equal to 5, F equal to 1, G equal to 3, and the coefficients of second fundamental form as small equal to 3, F equal to 7, G equal to 3. We compute the Gaussian curvature K. Okay. Now we try to see that Gaussian curvature is the determinant of this particular matrix. Okay. E, F, F, G, capital E, capital F, capital F, F, capital G. So, compute the Gaussian curvature K of the surface. Okay. To use the formula involving first and second fundamental form. Okay. Gaussian curvature formula is capital K equal to Eg minus F square divided by capital Eg minus capital F square. Okay. Where capital E, capital F, capital G are the coefficients of first fundamental form. Okay. Small e, small f, small g are the coefficients of second fundamental. Okay. So in case of your first fundamental form, capital E is 5, capital F is 1, capital G is 3. In case of your second fundamental form, small e is 3, Small f is 7, small g is 2. Now you try to calculate the coefficients. Okay, small eg minus small f square and capital EG minus capital F square. Okay, these you try to compute. Yeah. So, small eg minus f square. Okay, this is 3. Okay, capital E, capital G, which is 5 into 3 minus 1 square. This consists of your denominator. Okay, whereas numerator will be what? 3 multiplied by 3. Okay, minus 7 square. 3 into 3 minus 7 square. That is nothing but 9 minus 49. That is minus 1. Capital EG minus capital F square is 5 into 3 minus 1 square. That is 15 minus 1. That is 14. What is the final result? Final result is capital K. Okay. Capital K is nothing but minus 40 divided by 14. This is nothing but minus 20 by 7 on simplification. So that would be our option number B. Yes, now you try to see what is Gaussian curvature. Okay, Gaussian curvature K is a measure of curvature of a surface at a point. It tells you how the surface bends by combining the curvature in two principal directions. If capital K greater than 0, then surface is locally shaped like a sphere, okay, like positive curvature. If capital K is equal to 0, surface is flat like a plane or cylinder, 0 curvature. If capital K is less than 0, then surface is saddle shaped or negative curvature. Now, first and second fundamental forms compute the curvature. We need two key rules from the differential geometry. First one is first fundamental form. Okay, first fundamental form describes the metric, the axis, distance, and angle properties of the surface. It is written as capital I equal to E du square plus 2f du dv plus d dv square, where E is nothing but xu and xv, xu and xu. F is xu comma xv and g is xv comma xv. These come as the partial differentials from the surface parameterization, which is given as a function of x u comma. Now you try to see the second fundamental form. It captures how the surface bends in a space. It is small e du square plus 2f du du dv plus g dv square. E is xuu, means double differential. Yes. F is xuv. Okay, g is x, where n is the unit normal vector to the surface. Now, how you try to compute the Gaussian curvature? The Gaussian curvature relates to two fundamental forms y k equal to small eg minus small f square and divided by capital EG minus capital F square, where numerator is eg minus f square small m smalls and denominator is capital EG minus capital F square. In your particular problem, you have been given capital E is 5, capital F is 1, capital E is 3, and the second fundamental form is small e equal to 3, small f equal to 7, small e equal to 3. Now you just have to apply the formula in your numerator as well as denominator, and you have to write minus 40 by 14. That will give you minus 20 over 17. Please note down the question number 4. Choose the correct option. Options have been mentioned. 8 illumination levels are used in binary coding. Small n patterns must be projected in order to encode 2 square n stripes in space encoding. And every encoded point in binary encoding is identified by the sequence of occurrences that it receives. Every decoded point in space encoding is identified by the sequence of intensities that it receives. So try to just jot it down. take a note of all the points that have been given here. Then we will discuss this. Correct? Sure. Go ahead, you know. Now you see, rate illumination levels are used in binary encoding. This statement is true. Let us check. This statement is not true. Only B statement is true. Okay. Option number A was rate illumination levels are used in binary encoding. Okay. This one is incorrect. Why? Because binary encoding uses two levels. Okay. 0 and 1, not 8. And if you are using 3 bits, you can represent 8 values, which are from 000 to 111. But the illumination levels themselves are still binary. So yes, it is not true. Okay. Option number A is incorrect. In binary encoding, please do remember only two levels are used, not eight. Then option number B is n patterns must be projected in order to encode 2 raised to power n stripes in space encoding. This statement is true. Okay. Statement is true. Okay. Small n number of patterns must be projected in order to encode 2 raised to power n strips. Okay. This statement is in 100% correct. Why so? Because in your structured light, okay, with binary encoding, each pattern will have one bit encoded. Okay. So to distinguish between 2 raised to power n unique positions, you need n binary patterns. Okay. So this statement is true. Then option number C is every encoded point in binary encoding is identified by a sequence of occurrences that it is. Yes. This statement is incorrect. The term sequence of occurrences is wave. It is not a standard term. Okay. In binary encoding, a point is identified by binary code derived from multiple prolific patterns, not from inference. So option number C is not correct. So number D was every decoded point in space encoding is identified by the sequence of intensity bracket distance. This is also incorrect. In structured light encoding, points are typically decoded based on binary sequence code word. Which is derived from threshold intensities, which are either bright or dark. Okay. Raw intensities may vary due to lighting or surface properties. Hence, thresholded binary values are more advanced. Correct answer would be B. Small n patterns must be projected in order to encode 2 raised power n stripes in space encoding. This was your fourth question. Question number 5 was 5 is you have to consider a hyperbolic paraboloid which is represented as a parametric surface x u comma v equal to u comma v comma u. With u equal to 3t square plus 2t equal to 2t plus 1, and we have to compute all of the plus point in our entire form coefficients at to equal to. So you see, this is where correct option would be here. Option number D, which is none of the above. Why? Because in order to explain you first fundamental form. First fundamental form, I already tried to explain you in brief in question number 1. Okay. Sorry, in question number 2. I'll try to again explain you here also. Okay. First of all, you have been given a smooth surface which is parameterized by x u comma v, okay, which is x u comma v, y u comma v, z u comma v. First fundamental form encodes how lengths and angles of the surface relate back to u comma v in particular domain, in particular your line element from the surface will be dx. Dx equal to xu du plus xv dv. Now square differential length is double mod dx square, which is e du square plus 2f du dv plus g dv square. E is nothing but xu dot xu. F is xu dot xv. G is xv dot xv. E will tell you how the surface stretches in u direction. G tells you how it stretches in v direction. And F captures how skewed or non-orthogonal the economic grade is on the surface. Once you know E and G, now we can compute the length of any parameterized curve on the surface, angle between two parameter curves, and area element E. Okay, dA is in the root EC minus F square du dv and in the second fundamental form curvatures. Okay. So now you try to compute E comma F comma G for x u comma v, which is u comma v u. Partial derivatives x u is del over del u, u comma v comma u v, which is nothing but try to compute the partial derivatives, which is del u over del u is 1, del v over del u is 0, del over del u v over del u is v. xv is del u v u v over del v, which is nothing but delta u over delta v, which is 0, delta v over delta v is 1, delta uv over del v is u. Combining the dot products, okay. E is xu dot xu, okay. F is su dot xv, and G is xv dot xv. And try to see xu dot xu is 1 square plus 0 square plus v square. Okay. Try to compute the dot product wise, okay, which is nothing but m plus v square. Xu dot xv is 1 into 0 plus 0 into 1 plus v into u, which is 0. Xv into xv is 0 square plus 1 square plus u square, which is nothing but 1 plus v u square. When the E will be 1 plus v square, F will be uv, G will be 1 plus u square. So specifically, if you try to evaluate, ut will be 3t square plus 2t, vt will be 2t plus 1, and at t equal to 2, to get the value of u2 and v2 as 16 or 5. So E will be equal to, at 16, 5, this particular point, E will be equal to 1 plus v square, which is nothing but 1 plus 65 square, that is 26. F at 16, 5 is uv, which is 16 into 5, that is 80. G at 16, 5 is 1 plus u square, that is 1 plus 16 square, that is 257. So the geometric interpolation at t equal to 2 is t equal to 26. Means that small step du on the surface at that point have square length of 26 du square equal to 257 means a small step dv has a square length of 257 du square equal to 80 will indicate that the first term moving in u and v together is orthogonal. It is skewed by d by du dv. Okay. These three numbers will fully describe how your infinitesimal distances and angles remain on the hyperbolic domain. Now to find the first fundamental form, coefficients for the hyperbolic paraboloid, okay. Capital small x v comma v is u v u v. Okay. You complete the partial derivatives x u and x v. Okay. Then you form E, F, and G. Then you evaluate at t equal to 2. Okay. Now you plug in EFG. Okay, plug into EFG. Then you try to match with the options. E is 26, F is 80, and G is 257. 257. So option should be D, then I'll do the as not option will match. Yes, no option is matching. So D number will the correct one. Now question number 6. It is which of the following statements are not true for detection of edges in range image? Roof edge points are detected from zero crossings of Gaussian curvature. Step edge points are detected from zero crossings of Gaussian curvature. Step edge points are detected by the extreme of dominant principal curvature corresponding to its direction, or roof edge points are detected by the extreme of dominant principal curvature. Is what we try to see. Correct option would be A or C. In your range image edge detection, we try to distinguish between step edges, which are depth discontinuities, and edges, which are edges of fresh lines. The standard detection rules are step edges are located at zero crossings of the Gaussian curvature plane. Roof edges are located with the extreme of the dominant principal curvature, that is the larger of the two principal curvatures along its direct curvature direction. Now we will check each statement stepwise. Okay. Roof edge points are detected from zero crossings of Gaussian curvature. No, this statement is false. Zero crossings of K detect step edges, not roof edges. Statement is absolutely false. Then statement B is step edge points are detected from zero crossings of Gaussian curvature. The statement is true. The C statement is step edge points are detected by the extreme of dominant physical curvature in two direction. Yeah, this is also false. Extreme of principal curvature located roof edges, not the step edges. Okay, one step can be like the first. Then D part is roof edge points are detected by the extreme of dominant physical curvature from two direction. Yes, the statement is true. Therefore, correct option would be option which are not true are A and C, and which are true are A and C. Now, if I try to explain you what is range image and surface geometry, the range image gives you at each pixel I comma j a particular depth value, which is z, dij. Okay, you can view this as a sample surface. Okay, capital X UV is UV D UV. Okay, X Y Z. So similarly, I have written here U V D U. Grid space. In order to detect edges, we look at how the surface bends. So curvatures on the surfaces at each point on the smooth surface when compared to principal curvatures, which are K1 and K2, which are the maximum and minimum normal curvatures. When you slice through through that point in different directions. So normal curvature in a given direction T is how sharply the surface bends in that direction. Okay. And the two external values of these are K1, which is the larger curvature, and K2, which is the smaller one. So Gaussian curvature is K, which is K1 K2 product. Mean curvature is capital H, which is half of K1 plus K2. So step edges via Gaussian curvature zero crossing. What is a step edge? It's a depth discontinuity. One side of the edge is far, either one is near. That is your step edge. Why Gaussian zero crossings? When the surface steps abruptly, okay, one principal curvature becomes large positive, okay, which bends towards the camera, okay, and the other is a large negative, which is bending away from the camera. So K1, K2 product goes from positive to negative or vice versa. So our zero crossing in K will map it to K1, K2 to 0. Okay, there is no curvature. Changes sign signaling a respect. Reflection rule is scan for the pixels where K changes sign, where there is zero crossing of K. These are your steps, edges. Then what are roof edges? Via principal curvature extreme. What is a roof edge? Roof edge or the crest line in the surface which is continuous in depth but has a twist in direction, also known as ridge or roof. So why extreme of K1? At a ridge, the surface bends mostly in one principal direction. Okay. So K1 reaches the local maximum along its own curvature direction and equivalently If you follow the direction in which the sector is going to invest, which will have top key here. Yeah. Okay. Now, what is detection rules? Okay, compute K1 at each pixel. For each pixel, you will look along the K1 direction. Okay, in the tangent plane and test where K1 is local maximum. The maximum will be your loop edges. Why not to mix them up? Step edges are about sand flipping curvature, and loop edges are the peaks in bending magnitude along the smooth crest. Together, these two criteria will make you robustly separate that discontinuity edges from the next range type is values. So this quick repair for the four statements. First statement is false. The second statement is true. Third statement is false. And last statement is also true. Moving forward to the next question, question number 7. Consider the coefficients of first fundamental form, which are given by capital equal to 2, capital F equal to 3, capital G equal to 7. Coefficients of second fundamental form is small e equal to 4, small f equal to 0, small b equal to 3. You have to compute the mean curvature vector. Try to solve, then we will discuss. Please jot it down. Okay. Please jot down the question. Then we'll try to discuss. Okay. And try to solve yourself also this particular question. Then I'll show you the solution. Okay. Please try to jot it down. Okay. Yes. Now you try to see, okay, what are the different concepts involved in this particular problem. Consider the covariance of first fundamental form we given by capital equal to 2, capital F equal to 3, capital F equal to 7. Coefficients of second fundamental form as small equal to 4, small f equal to 0, small g equal to 3. You have to compute the mean curvature h. Okay. What is mean curvature? Mean curvature h measures the average bending of a surface at a point. It averages the two principal curvatures given in K2. Since if h is equal to 0, surface is minimal. If h is greater than 0, it bends towards the normal. If h is less than 0, then the surface bends away from the normal. Now, we try to see from principal curvatures to fundamental forms. Okay. Computing K1 and K2 directly requires solving eigen problem in the shape operator equivalently in terms of first and second fundamental forms. These are closed forms. First fundamental form is I equal to E du square plus 2F du dv plus C dv square. It encodes how distances or angles on the surface relate to changes in the parameters U, V. And in case of the second fundamental form, which is E du square plus 2F du dv plus G dv square. Okay. That will capture how the surface curves in a space via dot products within the event. So formula for mean curvature is in terms of EFG or small AFG. You can show that K1 plus K2 is PG minus 2 capital F small f plus GE over PG minus F square. And H is given by PG minus 2 capital F small f plus GE over 2 PG minus F square. Numerator will denote how the directions curvature varies against the metric. Okay. And denominator normalizes the area distortion of the parameter. Now, geometric interpretation is the denominator, capital EG minus E square is the determinant of the metric. Okay. It's proportional to the area element under root capital EG minus F square dV. Okay. And the numerator will effectively integrate the bending in two parameter directions, subjecting any mixed bending twice. Okay. So capital H will tell you how per unit area how much the surface is damaged. In our example, we just applied, okay, numerator to numerator. So the value we'll try to compute. We will get the value as 3 point. Yes, all the calculations have been shown here. Please, after the session is over, okay, do try to compute yourself. Okay, try to see whether you are getting the same result or not. If you are not getting the same result, then we will discuss. Then question number 8 is, which of the following are examples of active imaging? Okay. First one is time of flight sensors, then it is triangulation based sensor, then structured light or stereo. So yes, correct options are A, B, and C. Okay. Time of flight sensors, triangulation based sensors, as well as structured light sensing are the examples of active imaging. Okay. Active imaging modalities, okay, those which emit their own probing energy are TOF, then triangulation based sensor, then structured light, and stereo imaging is passive. Okay, it relies on the hundred illumination of the object. Okay, active imaging refers to any technique where the sensor actively emits the magic, okay, into the scene and then it's returned in order for that for shape. By contrast, passive imaging lies purely on embedded image. So TO of sensing or time of flight sensors, they uh, send a pulsed infrared light source. Okay, emit short bursts of light. The sensor times. Okay, how long each pulse takes to travel to the object and time. This is T of sensing, time of rate sensing. Depth is c delta t divided by 2, okay, where c is the speed of light. Okay, since we are using light only, light as the primarily object. Okay, so here the speed of light will be only considered c into delta t divided by 2. Why it is active? Because it generates its own IR pulses rather than waiting for ambient reflections. So pros are the pros and cons are very simple for pixel measurement in limited range accuracy by timing precision. Okay, multi-path reflections and interference can use classes. Then triangulation based sensing, okay, they work by single laser uh, dot or line is projected onto the scene. Camera data, no baseline outside sees the laser spot displaced. Okay. By simple your triangulation geometry, the displacement will match to the depth. Okay. That is triangulation based sensing. Using the known baseline B, projected focal length F, your observed disparity or the distance D would be B small f divided by Z, where D is equal to Z. Okay. Why it is active? Because it shines in a structured laser, okay, rather than passively capturing a bright light. High accuracy on the illuminated region, these are the cross, and only one line requires a scanning for a full field. Reflection. So, okay. The structured light systems, projector casts a known pattern, okay, over the entire scene in one or more snapshots. Camera observes how that pattern deforms on the surface. That is your structured light systems. In-depth computation by measuring each load pattern statement to its known projector coordinate, you can form a triangulation relationship. Then it is your depth computation. Why it is active? Because it actively projects coded illumination rather than relying on ambient. And what are the pros and cons? The pros are captures dense depth image maps into keyframes, and it is susceptible to the entire interference. You know, stereo imaging, how it works? Right. It works by uh, capturing two passive cameras capture the scene under ambient light. Okay. When corresponding points are matched across images, depth is inferred by their disparity or shadow. Okay. So depth computation is 1z equal to df over d. Okay. Just like in case of your triangulation. Okay. Why it's passive? Because it does not project any light. It only records whatever the illumination is available to that. It works outdoors in the textured scenes without any lighting, and lighting influence on textured less or repeating patterns. It requires robust steering. So yes, TO flensing it is active. TO light sensing it is active. Triangulation based is active. Structured light is active, but storage imaging is not active. It is passive sensing. Because it requires passive cameras and disparity matching. A, B, and C are active. D is passive. Then coming to the next question. Which of the following uses laser radar sensors or your radar sensors? It is the of light sensing, it is triangulation based sensing, it is stereo imaging or structured light. Okay. Correct option is A. Okay. And your sensing. What is LiDAR? LiDAR is light detection and imaging. Okay. Also known as LiDAR. It's a type of UF system that uses laser pulses to measure the distances. It emits the short burst of laser light, measures the time delay of reflected light, will be depth. It's highly precise, works over the long distances. It's common in autonomous vehicles. as well as an aerial mapping. Okay. This is for LiDAR. Then option number A is TOF sensing. Yes, it is correct. The LiDAR is active type of TOF sensor using laser pulses. So LiDAR is yes, laser-based TOF sensing. Option number B is triangulation-based sensing. No, it is incorrect. Means use projected laser dots or lines that do not measure TOF. But if we use geometric triangulation, no, LiDAR makes sense. Then stereo imaging, this is also incorrect. Okay. Purely passive technique, no active laser or light emission is there, so not LiDAR. Okay. Then structured lighting, it is also not correct. Okay. Projects known patterns or the strips or dots, not exactly the laser pulses for POS. So it is active. LiDAR. So final answer is TOS. So common principle, physical principle, TOF of laser pulses. First generation is a near infrared laser diode or solid state laser units, extremely short pulses within nanoseconds or picoseconds wide. And pulse energy and repetition rate are engineered for range, resolution, and eye safety. And propagation and reflection, the light travels at c, which is speed of light, 3 to 10 is per 8 meters per second. It reflects off the surfaces and returns towards the sensor. And detection and timing, first photodetector will capture the returning photons, and high precision timing, electronics measures the counter delay delta T. So Z equal to C delta T divided by 2, dividing by 2 counts for the outbound and return ones. So what are the key components of LiDAR system? First of all is laser emitter, then beam steering, then receiver optics, then photodetector, and PDC. Time to digital converter, then processing. Okay, with that, the key components. The types of LiDAR is pulse LiDAR, then continuous wave LiDAR, and why triangulation and structured LiDAR not LiDAR? Because it is based on triangulation based. And structured light projects the known spatial pattern, so how the of measurement is directly taking place. In case of passive stereo, okay, two cameras capture ambient light, and the Z is the depth disparity. From disparity mapping, it is Z equal to Vf divided by T. So no energy is injected, tends to envelope texture of HMS cells. So in case of your autonomous vehicles, okay, LiDAR is used. In case of your aerial mapping, LiDAR is used. In case of industrial robotics, yes, it is used, and augmented reality also it is used. In some, LiDAR emits pulses, time returns to LiDAR is good light. Triangulation based and structured light, yes, also active, but rely on geometry of pattern displacement, not on timing. And stereo is passive, hence no emission is there. So we are sensing a LiDAR systems. Question number 10. Any question for the current session? Okay. Choose the correct options regarding the digital neighborhood pattern planes, DNPs. Okay. For a 3D neighborhood of a point P, the number of principal planes are 3, number of diagonal planes are 6, total number of digital neighborhood planes are 9, and total number of digital neighborhood planes are 8. Correct options would be A, B, and C. The DNPs or the digital neighborhood planes in a 3D grid are the distinct planar cross sections through a central voxel, okay, P, that align with either the coordinate axis or the diagonal directions. Okay. So concretely, principal planes are the axis aligned planes which pass through XY plane, YZ plane, and ZX plane. Okay. These are exactly three of these. So diagonal planes are 45-degree planes in each principal plane, that is two lines x equal to plus minus y within the xy plane, y equal to plus minus z. Within the yz plane and z equal to plus minus x within the zx plane. Okay, each principal plane contributes to such diagonals, a total of 3 into 2 equal to 6. D is the number of principal planes. 2 is the diagonal number of planes. And total you will get 6 number of planes. So total DMP is simply the sum, that is 6 plus 3 is 9. Correct options are number of principal planes is 3, number of diagonal planes is 6, yet the number of DMPs is 9. Option D is correct. And your 3D or discrete grid, okay, DNP or digital neighborhood plane is any planar slice through the central voxel P. It passes through P, okay, and aligns with either the coordinate axis or the principal diagonals of the two of its immediate neighbors. These planes are used, for example, in 3D thinning here. We take this three standard coordinate planes passing through P, XY plane, YZ plane, ZX plane. So there are three pairs of coordinates axis, X, Y, Y, Z, and ZX. These are exactly three principal planes. Diagonal planes within each principal plane so can slice along the 245-degree diagonals of the square neighborhood for XY plane. These are the line Z equal X equal to Y and line X equal to minus Y. Analogously, okay, analogously, in YZ plane, it would be Y equal to Z and Y equal to minus Z, and in ZX plane, it would be Z equal to X and Z equal to minus X. So each of the principal plane will contribute to two diagonal slices. Total you will get 3 into 2, that is 6 diagonals. So total number of DNPs is 3 plus 6 equal to 7. They matter because of the connectivity and topology. Okay. When you remove or retain pixels in 3D image, okay. You can check NHD neighborhood configurations in this DMP to avoid breaking connectivity. And planar feature or ridges aligned with these discrete planes that we originally detected by analyzing the corresponding elements. So this marks the end of the 10 questions which I wanted to discuss. Thank you all for joining the session. We'll do the session next week, same time, same day. Okay. Thank you very much. Okay. Thank you. Thank you. Okay. Thank you all for joining this session. I'm ending the session for you all guys. Thank you. Thank you very much.